Consider the random experiment of rolling two dice and observing the pace on each. Assume the dice are fair so that each outcome is equally likely. Define the random variable y, sum of the two paces. First, let me write down the sample space. There are two dice, therefore we should have 36 elements in the sample space. Then we can define the y and the support of the y. What is the support of y? How do we find it? Yes, think about the first element in the sample space, which is 1, 1. Then what is the sum of that? 1 plus 1 is 2. Then 2 is in the support of y. Then go to the second element, that is 1, 2. So 1 plus 2 is 3. Similarly, you can find the support of y. Go to the part A. Part A is asking first probability y equal 2. Then find the elements that make the sum 2. So that is only this element 1, 1. How many elements we have of this case? Just 1 out of 36, because in the sample space there are 36 elements. Therefore probability is 1 over 36. Then go to the second part. Probability y equals 7. First, find the elements in the sample space that the sum makes 7. There are 6 elements. So there are 6 elements out of 36. Therefore, probability is 6 over 36, or you can say 1 over 6. Then go to the probability y equal 21. Do we have any element in the sample space that sum make 21? No, we don't have any. Therefore, it is empty. So what is the probability of the empty set? It is 0. So probability is 0. Now go to the part B. Describe the probability mass function of y. First, we need to find the support of y. Yes, we do know that. Then we need to find the probabilities of each element of the support of y. You can find the probabilities that I explained under part A. So first write down the support, then find the probabilities of each elements in the support. So that this is the probability mass function of y. This is not the only way we can write. It is also possible to represent the probability mass function of y as a formula. So you can write the probability mass function as a formula like this. You see here y has the element 2 to 12.